Good day to you from Chem Help ASAP. Let's see a different nucleophile attacking a carbonyl. The reaction of hydrides with a carbonyl is just like organometallics. Here is our reaction. On the left, we have a ketone as our starting material. It is a weak electrophile. Over the reaction arrow is our key reagent, lithium aluminum hydride, or LAH. Written as text, lithium aluminum hydride looks innocent. So let's remind ourselves of the fact that this is a source of hydride by writing an H- above it. Now that looks like a strong nucleophile. The hydride attacks, breaks the CO pi bond, and gives us our tetrahedral intermediate. When attacking a ketone or aldehyde, the tetrahedral intermediate will almost always be protonated in the next step. With lithium aluminum hydride, however, we normally use an ether solvent, often THF. So THF is this. It stands for tetrahydrofuran. So, because lithium aluminum hydride reacts vigorously with even weak acids, the reaction is free of any acidic protons. There's no water around. For this reason, we have a second step. Once the reaction has formed the tetrahedral intermediate, then, in a second step, we add water, and water protonates our O- to get the alcohol. In this reaction, we have performed a nucleophilic addition. If you look at what we added, it is 2 hydrogen atoms. When we add H2, we call the reaction a reduction. So, we might say that we did an addition on the ketone. We might also say that we reduced the ketone to an alcohol. Either would be appropriate. Aside from lithium aluminum hydride, we have another hydride reagent, sodium borohydride. It's on the right. It reacts almost the same as lithium aluminum hydride, but there are differences. We have a reaction that involves sodium borohydride. Again, we start with a ketone, the same ketone. The hydride is over the reaction arrow. Let's label it as an H-. Notice, however, there is only one step. That's not an oversight. We don't have a second step to add the proton to the tetrahedral intermediate. The reason is the reactivity of sodium borohydride. Sodium borohydride is less reactive than lithium aluminum hydride, and we can actually use an alcohol like ethanol as a reaction solvent. Like water, alcohols are weakly acidic. As soon as the tetrahedral intermediate forms, here's our mechanism. Here is our tetrahedral intermediate. As soon as that forms, the alcohol solvent can protonate the tetrahedral intermediate and give the same alcohol. We do not need a separate second step, a number 2 step, in order to add the proton source. Sodium borohydride and lithium aluminum hydride are used similarly, but lithium aluminum hydride requires a second step for protonation of the intermediate.